Hello, this is Dr. Mears, and today we are going to be multiplying and dividing rational expressions. Let's begin. Number one, we have 5a cubed divided by 4 times 2 divided by 5a. And we're going to first use the factor method. As you can see, I already set it up. I wanted you to see what it looked like from the get-go. All I did for the denominator was I just moved over the 5a times 4. That's it. And I did one fraction bar here. In the numerator, I split up my 5a cubed to 5a to the first times a squared times 2. So now everything is revolving around that one fraction bar. That's what we want to do. Bring everything together and factor it. The reason why I separated these is because I can cancel those out, because 5a divided by 5a is 1. I can also reduce 2/4. I can reduce 2/4 to 1/2. And so that gets rid of that. A squared remains in the numerator. So my answer is a squared over 2. Now, you could have done this another way, and this is absolutely fine, either way you prefer. You could multiply just the numerator, 5a to the third times 2. That's 10a to the third. And you can multiply the denominator. 4 times 5a is 20a, and that is to the first power. Then you could have reduced 10/20ths to 1/2. A to the third divided by a to the first. We subtract exponents. A to the third divided by a to the first is a to the 3 minus 1, which is a squared, a squared. So you get the same answer. This first way we factored, and then we reduced. This way we multiplied, and then we reduced. Either way will work. However, I'm going to focus on this way because we're going to have to factor. So I don't want to multiply here. That will get way too messy. And this came out really nicely. Okay, so what are we going to multiply next? So we're going to go with factoring way. That's the way we're going. All right, we have x squared minus 3x minus 10 times x to the fourth divided by x squared minus 10x plus 25. First, let's put this over 1. This was not in a fraction, so let's put it over 1, because what I want to do is I want to bring everything together. And so here I'm just going to do x squared minus 3x minus 10 times x plus 4. When I bring it together, I'm going to put parentheses on everything, all divided by 1 times x squared minus 10x plus 25. Now, once I have it revolving around one fraction bar like I do here, let's factor everything and see what we can cancel out. This is the fun part, and this is why I focus so much on factoring, because once you're good at factoring, then you're ready to go and we can cancel things out. All right, let's factor x squared minus 3x minus 10. And so x squared minus 3x, what multiplies to 10 and adds to 3? We're going to get x minus 5 and x minus 5. Yeah, x minus 5 and x plus 2. There we go. Negative 5 times 2 is negative 10. Negative 5 plus 2 is negative 3. We're good. We didn't have to worry about an a value, so we didn't have to do that multiplying here. We didn't have to do any of that. We can't factor x to the fourth, so we're going to bring it over. Don't forget to move this over here. Let's factor the denominator. What multiplies to 25 and adds to 10? You got it. X minus 5 times x minus 5. Negative 5 times negative 5 gives you positive 25. Negative 5 plus negative 5 gives you negative 10. Again, a was 1 here, so we could use that easier factoring method. Now the fun part comes. We get to cross things out. So we need to find what's like in the numerator and denominator, and we cross it out. So we see we have an x minus 5 here and an x minus 5 here. We can cross them out. The reason we can cross them out is because everything is linked by multiplication. Reason we can cross out is because everything is linked by multiplication. And we were able to get it into multiplication because we factored. So this is another reason why factoring is so important, because we're able to multiply and divide rational expressions. So that's what we want. So we're able to cross out those two. Are there any other like? Nothing is alike, so we're just going to write x plus 2 times x plus 4 divided by x minus 5, and that's it. That's your answer. Move on. Okay, let's try number 3. We have 10x plus 20 divided by 2x squared minus 3x plus 1, and then x squared minus 1 divided by 5x plus 10. Let's bring everything together. We got 10x plus 20 times x squared minus 1. I went way too overboard with my fraction bar here. Okay, we got 2x squared minus 3x plus 1 times 5x plus 10. Now, no, we have nothing similar here, but when we factor, we're going to find something similar. All right, so let's factor. Let's start with 10x plus 20. Just looking at that, is there a greatest common factor? Hopefully you're going to say, yes, I can pull 10 out, and I have x plus 2 left. Great. Here, just looking at x squared minus 1, hopefully you're noticing that these are both perfect squares. So this is going to be x plus 1 times x minus 1. And it doesn't matter the order, everything's multiplication, so we can just rearrange it. We can find, they don't necessarily have to be like on top of each other like this. As long as everything's linked by multiplication, we're going to be able to cross things out. All right, let's look at the denominator. So we're all finished with the numerator. We have 2x squared minus 3x plus 1. So a little side note over here to factor 2x squared minus 3x plus 1. Because we have an a value of 2, this is one instance where we multiply them. So we need factors of 2 that add to this middle term, that add to negative 3. And so hopefully you're going to say, all right, we have 2x squared. Our factors can be negative 2x times negative 1x. Negative 2 times 1 is positive 2. Negative 2 plus 1 is negative, plus negative 1 is negative 3. I'm going to put the negative 2x here, minus 1x plus 1. So I broke that 3x down. And then I am going to do the grouping. From here, I'm going to take a 2x, and I have x minus 1 here. Here, I'm going to do minus 1. Don't forget your sign. And then I have x minus 1. And so to factor this, I have 2x minus 1 times x minus 1. Okay, so I'm going to bring that up here. 2x minus 1 times x minus 1. And here's the thing. When you factor, you're going to know that there's going to be some common factors. So that can be a hint for everybody. That can be a hint for you. If you kind of get confused, you can always factor this one last, because factoring this one right here, 5x plus 10, is a greatest common factor. So this is going to be times 5 times x plus 2. So I just took a 5 out, x plus 2. That was the greatest common factor. So if you wanted to do this one last, if it was a little bit more work for you, it will give you a hint that we're going to cross things out. So the more, this is practice. So the more you practice these, you're going to see more patterns, and they'll be able to go a little bit quicker. Okay, so this is the fun part. Let's cross things out. So I'm going to put the fraction bar. 10 divided by 5, I can reduce that. So 10 divided by 5 is 2. Okay. And when you divide that, unless it's a fraction, the 2 goes on top. If it was 1/2, then it would be 1/2, but it's not. It's 2. So just goes there. All right. So that's good. All right. Let's see. What do we have similar? X plus 2, x plus 2. Perfect. Let's cross it out. Done. Okay. Do we have an x plus 1 in the denominator? Nope. All right. Let's bring that down. X plus 1. All right. Do we have an x minus 1 in the denominator? Yes. Perfect. Out, out. So they're matching. It's kind of like the matching game. Remember when you were playing with cards, you would turn it over? You would have a match. It was like, yay, you get to keep those cards. And 2x minus 1, we're all done. So we're just going to bring 2x minus 1. And guess what? That's it. That's our answer. So if you could really get through the factoring part of it, the rest hopefully will just show itself. What matches? Let's cross it out. Let's reduce 10/5 to 2, and you'll be good to go. Okay, let's see. Thinking division's up. Yep, division. We just have a few a few with division. Division is very similar with multiplication, but remember in dividing fractions, we are going to have to multiply by the reciprocal. All right, what does that mean? So instead of putting one fraction bar, let's keep the fraction x over 5, multiply by the reciprocal. So the division changes to multiplication, and 7 and y are flipped. That's what we mean by reciprocal. We flip it. Now what we can do is we can just one fraction bar. X times y is xy. 5 times 7 is 35. Nothing to reduce. Call it a day. That's it. Okay, let's move on with the next one. So we have, and I'm going to throw parentheses on this. I really like to do that. It helps me keep all my expressions together. We have x plus 2 divided by x minus 1 divided by x plus 3. I'm also going to put this over 1. It's not a fraction. I like when I'm dealing with fractions to have everything in fraction form. Now let's go. We're going to change it to multiplication, take the reciprocal. So that flipped. Okay, now I can do one fraction bar, x plus 2 times x plus 3. 1 times x plus 1 is just x plus, oops, I meant x minus 1. Let's make sure I have all my signs. Yep. Is there anything that's in common between numerator? Nope. That's it. We call it a day and we move on. Okay, let's keep going. You know they're going to get a little bit more complicated. These are probably the basic examples, just to see, do you understand that we do have to multiply by the reciprocal and then we bring it all together? Yes, we're going to be getting into the factoring ones. And guess what? This factoring one, you're going to see a lot of the same type of factoring ones are going to come up, so you'll get practice. Okay, let's first, we have x plus 1 divided by x squared minus 1. We have division, so we need to make it multiplication, multiply by the reciprocal. Once we have that, we can then do one fraction bar. And already we have here, we have x plus 1 and x plus 1. If you want to cross that out, you're more than welcome to. So, you can eliminate as you go. I think my pen's starting to run out a little bit. So, perfect. We saw that we had similar. Get it out of there. We don't need to deal with any more. And my pen's running out, so we're going to switch to green. Okay. So we got fraction bar. And let's factor this. So this factored is going to be there. Now a is 1, so we could just say let's multiply to 1, add to 2. So x minus 1 times x minus 1. Negative 1 times negative 1 is 1. Negative 1 plus negative 1 is negative 2. And then let's factor this one. Hopefully you see this is right difference of squares. So, oops, I said squares and I wrote it at the same time, everybody. Okay. X minus 1 times x plus 1. What do we have in common? X plus 1, x minus 1, out. And what do we have left? X minus 1 over x plus 1, and that's it. That's it. So our added step is first, you have to realize you're dealing with division, and then you're going to have to multiply by the reciprocal. And it's following through the same steps, one fraction bar, factor, cross out. And our last one for the day, x squared minus 2x minus 3 divided by x squared minus 4 divided by 7x plus 7 divided by x plus 5. So we have x squared minus 2x minus 3, and then x squared minus 4 multiplied x plus 5, 7x plus 7, one fraction bar, x squared minus 2x minus. If you want to factor here because you know that you're just going to combine everything, you can factor here. I'm just going to show, I like just to show all the steps, especially the first time. Seeing this and learning this for the first, I already said first time, learning this, I show all my steps. All right, one fraction bar, let's factor. A is 1. I love when A is 1. And I'm not going to get complicated because we spent so much time on factoring, everybody. I'm just going to keep it relatively on the less complicated side for factoring, just so that I know, hey, we got to factor these so that we can cross out our like expressions in the numerator and denominator. So I'll try to keep A1 just so that we could do the what multiplies to -3 and adds to 2. And so we're going to see -3 times +1 gives you -3. -3 plus 1 gives you 2. Perfect. Don't forget your x plus 5. And here you're going to see, right, difference of squares, x squared. So x plus 2, x minus 2. You're going to see this a lot, just like we saw here. So these are going to pop up a lot. This one will probably pop up a lot for factoring. 7x plus 7, can we factor anything out? Yep, we can factor a 7 because that's the GCF. So we can take a GCF out of that. So 7, and we have x plus 1 left. Okay. What could we cross out here? Let's see. Do we have any x minus 3s? No. It's like go fish. All right, so that's out. Do we have any x plus 1s? No. No, wait. Yeah, I do. Just kidding. You're like, wait a minute. Mears, we have an x plus 1. We just wrote it. My bad. We have, yes, right here. X plus 1, x plus 1. Sorry. Do we have any x plus 5? So x plus 5. Okay, that's out. And then, nope, everything we can rewrite. I like to rewrite the 7 in front. 7 times x plus 2 times x minus 2. I always like to write that number if there's a number. And that's it. We noticed it's division. So we had to multiply by the reciprocal. We brought it together with one fraction bar. We factored what we could. We cross out what we needed to. And this is our answer. And that's been multiplying and dividing rational expressions. Hope it helped.